What's up everyone, Patrick here, welcome back. Moving on to the next question, dealing with quadratics. So we've got to find the coordinates of the vertex of y equals ax squared plus bx plus c in terms of a, b, and or c. So notice in this case, we're going to be keeping it general. There's no numbers involved here. So what we got to do is find the coordinates of this general form quadratics, or we have to find the coordinates of the vertex of this general form quadratics that is in standard form ax squared plus bx plus c. And so what we're going to have to do on this is complete the square, and then once it's in vertex form, we can then get the vertex. So this one's going to be a little bit trickier versus just dealing with numbers. And to make the process a little bit more smooth, let's maybe go through an actual quadratic on the side so you could see how this process is going to be the exact same process as if we're dealing with an actual quadratic. So let's maybe do 2x squared plus 4x, let's do plus 1, like that. Okay, so we're going to complete the square on both of these using the exact same process. So what is the first step here? Well, we factor out a 2 from these first two. So we'd end up with x squared plus 2x, and then we got a plus 1 at the end, like that. And then how did we get these terms here? Well, we took both of these and we divided by what we took out. We divided by this 2, right? 2x squared divided by 2 is x squared, 4x divided by 2 is 2x. So the exact same thing here is going to apply. We're going to take out this a that's in front. Ax squared divided by a. The a's cancel out, so we're just left with x squared here. And then we got plus. And then what is bx over a? Can't simplify that in terms of these letters here, right? Nothing is canceling out. So let's actually just write this remaining term as b over a x. And then we got, and then we close the bracket. And then we got the plus c. Like that. So this b over a here in front of the x value, it's like this 2 over here. Okay, so hopefully you're following along so far. And then what is the next step? Well, we have to convert this quadratic that's in the bracket to a perfect square trinomial. What we do is we take this value here, that 2, we divide it by 2, and then we square it. So that would end up giving us what? 1 squared, which would end up giving us 1, like that. So same thing, that 2 in the numerator here, it's like this b over a. So what we're going to do is we're going to take b over a and we're going to divide it by 2. Instead of writing it like this though, because we're dealing with fraction expressions here, I'm just going to divide it by 2. It's like dividing by 2 over 1, and then we're going to square it, right? Remember, this b over a is like this 2 over here, and then we're taking that, dividing by 2, and then we are squaring it like that. So here there's going to be a little bit more algebra versus here. Here are numbers, here's expressions. So this would be like b over a times 1 over 2. That's going to be squared, so that would be like b over 2a. That's going to be squared, and then we could take the numerator, square it, and then we could take the denominator. We could square it. That would end up being b squared over 4a squared, like that, right? 2a squared, 2 to the power 2 is 4, a to the power 2 is a squared. So this b squared over 4a squared, it's like that 1 right there that we got for the quadratic. Both of those are equivalent. So what do we do with this one? Well, we take x squared plus 2x, and then we add that and subtract that, and then we got the plus 1 at the end. So we're going to have to take this expression, add it, subtract it within the bracket. So that would give us x squared plus b over ax plus b squared over 4a squared minus b squared over 4a squared, and then we got the plus c, like that. Okay, and then what's the next step from here? Well, we take the negative 1 out. And when we take it out, we have to multiply it by what's in front. So we've got to multiply it by this 2 over here. We got to take this out. We got to multiply it by what's in front. So we're going to multiply it by the a. So over here, we'd end up with 2x squared plus 2x plus 1. Then we got -1 times 2, which would give us -2. And then we got a +1 like that. So when we take this expression out, let's do it on the side here. Well, when we multiply it by this a that's in front, right? We're taking this expression, taking it out, multiplying it by the a. Notice here, this is like a over 1, this a, and then one of those a's cancel out. So we end up having -b squared over 4a, like that, after we multiply these. So that is what's going to go here. That's going to be like this -2 right there, after we multiply it by the a. So, following along, x squared plus b over ax plus b squared over 4a squared. And then over here we end up with -b squared over 4a, and then we got the plus c, like that. And then from here, remember this remaining bracket, it's always going to be a perfect square trinomial. That's where this process comes from. So this is always going to factor into x, and then half of that value, which is just +1, and that's going to be squared. This value here, it's always going to be this value over here after we take that and divide it by 2. It's always going to be the same as this. It's always going to be that divided by 2. And so over here, notice how, you know what, let's maybe start a new line here. So we'd end up with a, and then this is going to factor into x plus half of that value, which we already did the algebra of that, b over a divided by 2. It's like b over a times 1 over 2, which would give us b over 2a, and that's going to be squared. And then we still got the -b squared over 4a plus c, like that. And that here, over here, -2 plus 1, that's going to just net out to -1. Over here, we can't really net these out because there's no like common like terms. We can maybe combine these into one fraction. I'm just going to keep it like this. So this entire expression here is going to be like that -1. And I'm actually going to make it look a little nicer. I'll put the c in front. So what I'll do is we'd end up with x plus b over 2a squared, and then we'll have plus c minus b squared over 4a, like that. And then from here, what's the vertex over here? It's going to be -1, right? The opposite sign of that, and then this -1 here. So the vertex here, it's going to be the negative of this, -b over 2a, and then it's going to be this entire expression for the y value of the vertex. Okay, so it's a lot to memorize. So usually you're not memorizing this entire thing in order to get the vertex from standard form. But if you do remember this, it's actually a nice way to check your answer if you do end up remembering this, this expression here for the vertex. Because I could take something like this. Notice the a value is 2, the b value is 4, the c value is 1. We got a vertex of -1, -1 when we completed the square. Well, what would happen if we took this and plugged it into these expressions? We'd end up with -b, so we'd end up with -4 over 2 times the a value, which is 2. And then we'd end up with c, 1, minus b squared, which is like 4 squared, over 4 times a. So we'd have 4 times the a value of 2. And so if you do the algebra here, you'd have -4 over 4, which would give us -1. Then over here, you'd end up with 1 minus 16 over 8, which is like 1 minus 2, which indeed does give us that -1 right there. So if you do remember this expression, it's a nice way to check if you're getting that same vertex, right? So if they ask you for the vertex of a standard form quadratic that's given in general format without any numbers, this is the process to convert it to vertex form over here. Actually, I forgot this y equals, right? So this quadratic, they're the exact same thing, and then that ends up being the vertex.